So welcome back. Now we're going to talk about Terraform. So in that video, we are just going to create something on Azure Cloud, so on that cloud, Microsoft Azure Cloud, and we're going to use Terraform. So as I said, there are two main ways of how we can create things in cloud. First of all, you can go on some kind of portal. It can be an AWS, Oracle Cloud, Google Cloud, or Azure in our case, and you can create everything yourself. So today we'll create a resource group, and what we need to do is click here, we need to create, we need to add something, so on and so on and so on. It may be beneficial for some people, but for big companies, for projects that use automation, maybe we'll have some more better way of doing that. And that way is Terraform. So Terraform is a program by HashiCorp that allows you to write code that will deliver your infrastructure. So as you can see, deliver infrastructure as code. We'll write some code that will be applied to our cloud, and without ever opening a portal, we'll be able to create some resources and so on and so on and so on. So let's just start with Terraform. First of all, what you need to do is, of course, install the Terraform CLI. You can download it here. So the website terraform.io is in the description, and yeah, kind of like that. And then let's talk about registries. So in order for me to do that, I'll open a paint and I'll show you some crucial ideas. So we have many clouds. It can be something like Azure, AZ, it can be AVS, or it can be Google Cloud, GC. And because of that, we often need to use some kind of resource that allows us to really work with those clouds. So if we're talking about Azure, it can be Azure templates or AZ language. So AZ CLI. Let me just open it. Oh, sorry, that's the wrong button. AZ CLI like that. So AZ, that will allow us to work with Azure. And if you're talking about AWS, that's an AWS CLI, or if you're talking about Google Cloud, then maybe it's called Google CLI. I don't really know, but each of those clouds has its own CLI. And the problem with those CLIs is that we can't really write the code that will allow us to really put the infrastructure to the cloud. But with Terraform, what do? We have something called Terraform Registry. So Terraform Registry is like a GitHub for different Terraform modules and providers. We will not talk about modules, we will talk about providers. So provider is actually the CLI itself. So if we're talking about Azure, we need to use Azure provider. So if we're talking about Azure, we'll use Azure provider. If we're talking about AWS, we'll use AWS provider. Or if we're talking about Google Cloud, Oracle, or any other cloud, we'll use that cloud provider. So if we go to Terraform Registry and providers, you can see those right here. So that website is also in the description. As you can see, there are tons of providers here, and you can actually write your own providers. But today we'll once again work with Azure. So I'll click here, and yeah, it says like it's a public cloud, and we can use provider with that button. And as you can see, it does not open anything, but it rather gives us a code. So a piece of code, we can copy it, and we can go to our editor. So in our case, it's Visual Studio Code. And let me just create a file called main.tf. So tf files are the files that will allow us to work with Terraform. And what I'll do here is I'll just put that code in my file. So what that code does, and let me just quickly put features here, features like that. So what does that code tell us? First of all, we're telling that we want to use Terraform, so that's kind of like a block. As you can see, it's like a very unique markup language, so we are using Terraform and we require those providers. So once again, providers allow us to really work with the specific cloud. We can use multiple providers, but typically it's only one provider. It can be it can be Azure RM, AWS, Google Cloud, or anything else. In our case, it's Azure RM, and we're saying that you need to require providers. So whenever we run our Terraform code, we will need to download all of those providers, and we need to download them from that source. So in our case, HashiCorp/Azure RM is a unique identifier of Azure provider on our Terraform registry. So as you can see, HashiCorp/Azure RM. And we also have a version, and the version is right there. So version 2.890. It's the latest version, but if you want, what you can do is use those signs, so bigger than, lower than, to lower than, oh my god, what is that? Lower than, bigger than, to show what versions you may use in the future. So for example, if I put bigger than 289.0, then every version after that, so after that version, will be used or will be valid for my Terraform file. But of course, I'm not a fan of doing that because yeah, they may add some new functionality, then they may remove some functionality, and because of that, I often just put the version, like hard-coded version, so 2.89.0. Okay, and then we are saying that we need to configure our Azure RM provider, and we need to put those features. In our case, it's like an empty array, and you can actually remove it, but I'll just put it anyways, because typically you put those features. So once again, that thing tells us that we are using Azure RM to use, or we are using Azure RM to work with the Azure cloud. And that Azure RM provider tells us that we're gonna configure our Azure RM provider to use in that main TF file. And we can put some features here, but for now, let's just leave it as a blank section in our TF file. So what we're going to do now? Now, once we collected everything, we can open our CLI, and if you work with a CLI, what you need to do is use Terraform, and you'll be able to see all of the comments, and yeah, that means that your Terraform works fine. If not, then just follow the installation, and yeah, I think you'll be fine. But what I need to do now is use Terraform init. That command will allow us to download all of the providers. So as you can see, initializing the backend, initializing provider plugins, and as you can see, we received two new, well, a folder and a file. Terraform log HCL basically tells us that we'll use that concrete provider. So in our case, it will be HashiCorp Azure RM, so version, constraints, hashes, and so on and so on and so on. So it's like a compiled version of our Terraform required provider. So it's for the version control. So you will always put it in GitHub, and it will allow you to control the versions of your required providers. And also we have Terraform folder, and yeah, Visual Studio Code does an amazing thing by like putting all of those in one line, but we can see that we have Terraform provider Azure RM version 2.89.0 x5 exe. So what we did here, when we run Terraform init, we downloaded our exe file, so our provider for Azure, and now once we did it, we can really work with the cloud. So what we need to do now? Now we downloaded our provider, so everything is great, but we need to talk about two key concepts. So the first concept is state. So what is a state in Terraform? Imagine that we have our cloud, so our cloud C, and imagine that we have our local computer. Local computer does not know anything about cloud because it's like a local computer. Those are two separate entities. They are not connected in any way. Of course, we are connected since we're using Terraform. And by the way, I forgot to tell you one thing. If you're going to use Azure, then what you need to do is use AZ login to log into your Azure account. That's it. And you also need to install Azure CLI tools. Okay, so yeah, Azure CLI tools can be, I'll put a link in the description so you can find them. But yeah, you need to install them and log into your account. That's kind of a requirement. Okay, so now what we're doing here, we use Terraform on our local machine, but the problem is that we may already have some things on our cloud. So imagine that we have some resources on our cloud, or imagine that when we create some resources, so imagine that I create something in my Terraform. So I created a virtual machine, for example. We need to show that that virtual machine is already created. So we need to understand that, okay, my Terraform file, my Terraform code created that virtual machine or that set of resources. And because of that, we typically want to have something called state. Not typically, but we always have that state in our local computer, but it's better, I would say that it's better to put your state in the cloud itself or in a separate folder, but we will talk about that later if you want me to continue telling you about Terraform, because it's a very great thing. And yeah, but for now we will store our state on our local computer, but once again, it's better to put it in a cloud or somewhere separate from our local machine. Yeah, I will not tell you why, but you can guess. So we have our state here on our local computer, and that state file tells us exactly what happened in each point of time with our cloud. So in our case, if I create something, so if I add +1 resource, that resource will be saved in our state. If I remove one resource, that change will also be saved in our state. And everything is saved to your state. So your state is literally the state of your architecture, the state of your cloud. Of course, that state can't, well, it can, but with Terraform, it's really, really complicated to get all of the resources that already present in your cloud. There are separate tools for that, but we'll talk about that a little bit later, once again, if you want me to continue talking about Terraform. But for now, just understand that every change that you may make on your cloud will be reflected in your state file. Okay, so that is about state, and we also need to talk about plan. So we have plan, and plan is basically what we need to do right now. So imagine that I created one resource, so I created +1 resource. That creation, so the creation itself, will be in my plan. And once I apply my plan, so I'll apply my plan, so my plan is literally tells me what to do now. So what we want to do with our code. We can create resources, delete resources, change resources, and all kinds of stuff. And yeah, my plan tells me what to do right now. So we'll create some resources on the cloud, and after that, everything is, we'll create something on our cloud using our plan, and all of the changes in our cloud will be reflected in a state. So state is what we have right now. What state are we in? Plan is what we want to do. That's it. Okay, and now I think you understand what I meant by that, and let's go and talk about resources. So we need to create a resource. In our case, we'll create a simple, very, very simple resource group. So in Azure, resource group is kind of like a logical group for your resources. So imagine that we have virtual machines, VMs, and we have an array of different virtual machines, like 1, 2, 3, 4, 5, 6, with their IDs. So VMs, or resource group is kind of like a logical container for all of your resources. And it's like the most simple thing that we can create in Azure, and because of that, we'll create it today. So what I'm gonna do now is create a resource, and I have GitHub Copilot, very good thing, but as you can see, it tells me what to do. I'll deactivate it for a little bit. Oh no, I need to deactivate it like that for HCL. Okay, and what we are doing here, we're creating a resource. So if we're talking about that markup language, by the way, it's called HCL, so HashiCorp language. That is the language that we use in our TF files. What we're doing here, we're saying that we need to create a resource of kind Azure RM resource group. So we want to create Azure RM resource group. Azure RM resource group is kind of like our provider resource group. And after that, I need to tell what's the name of that resource is, test. And it's very, very important, because typically you always have names of your resources. It's just like very, very representative. And because of that, what we are saying here, resource Azure RM resource group test. But actually what it is if we convert it to normal programming languages, it's like var, so resource is var, like identifier of a variable, then type of our variable, for example, integer, then name of our variable, test, equals to something. And that may seem very, very strange or odd, but what we're telling here is you need to create a resource of kind resource group with the name of test. But that name test is not the name in the cloud itself. It's not the name in Azure or AWS, Google Cloud. All of those principles apply to every possible provider. We're saying that the variable or the resource inside of the Terraform file, so resource in our code, will be called test. But if we want to give it a real name, we need to use name variable inside of those brackets. So I'm saying that you need to create a resource group with the name test. It's the name of the variable, but the real name in the cloud will be something like test resource group, for example. And after that, we also need to provide a location. So those things inside of here are the various variables, various fields that you need to show, or that you need to write when you set up your resource group or whatever. So for different resources, it will be different. But for now, what we need to do is create a name and a location. In our case, location can be West Europe, like that. So we are saying that we need to create variable test with the name of test resource group and location of West Europe. And we are kind of done. We're kind of done here. So what we can do right now is use our Terraform CLI. So I'm going to run Terraform Plan. So I'm saying that you need to plan. Once again, plan is what we need to do. You need to plan and put that plan, so out parameter, inside of a file called tfplan. So Terraform plan what you need to do right now. In our case, it will create a new resource group and put that plan inside of our TF plan. As you can see, once I run my plan, we receive our TF state because we changed our state. And well, we haven't changed it right now, but we'll change it once our plan is applied. And we can see what it does. So Terraform will perform those actions, so it will create some stuff. It can be changed, delete, or whatever. And after that, we'll create Azure resource group test will be created. And as you can see, it just literally creates our resource group. We also have one additional parameter, which is ID. So in Azure, every resource has its own ID. And as you can see, it says known after apply because we don't know it yet. We will always create an ID once we created our resource. So ID is assigned by default. We don't assign it ourselves. And yeah, it says that if you want to apply it, just run Terraform apply TF plan. So Terraform apply TF plan. We run it. Okay, so we run it and we need to receive some output. Yeah, I think that we are connecting to the cloud. And yeah, Azure resource group test creating and creation completed. So we created our new resource group. Now let's go to our cloud and let's go to resource groups. If I run or if I look for test resource group, like that, as you can see, I only have, yeah, test YouTube, but it updated. And as you can see, we have test resource group now. I did not create it using my hands. I did it using Terraform. That is very, very powerful because basically we can create any infrastructure that we want using code. And that is the whole idea. So let's clear our terminal and yeah, we can do whatever we want. We literally can write our infrastructure using the code. It's very, very powerful. If we want to remove everything, we can run Terraform Destroy. Yeah, it takes a little bit of time, but yeah, as you can see, something was destroyed. Oh no, it's not destroyed yet because we need to run yes, because we literally need to destroy something in our cloud, and that can be very, very dangerous in terms of production environments. And because of that, I need to confirm it, so yes. And after that, I think everything will be all right. Yes, you can see it takes some time, but it's much better and not that much. It takes not that much time. So yeah, destroying. So it tries to destroy our resource group. Let's refresh our page, and once the resource group is destroyed, yeah, it's still destroying it. So yeah, 10 seconds elapsed. I think that will be the last message. Yeah, and destruction complete. Resource destroyed. So now, if I refresh my page, I do not see anything because we don't have our test resource group in our Azure because we destroyed it. So that is the whole idea of Terraform. It's a very, very simple video, but I explained the basics of Terraform and we created our resource group. There are tons of things that you can use in Terraform, so you can use different modules, you can use different providers, multiple providers, you can use variables, you can use overrides. There are tons of things that you can do with Terraform. And that's why it's so powerful. So tons of companies use Terraform, and yeah, it's basically, you basically can do whatever you want with your cloud without using the UI of the cloud at all. And that is much better because now we can recreate our structure. So if I want to literally create it, what I need to do is Terraform. So imagine that I have like 100 lines of code here. So I have different databases, replication, all that stuff. Terraform plan out TF plan. Easy. Let's wait for a little bit. And yeah, by the way, it allows me to recreate my plan, and it will not give me any errors because once we deleted our resources, we updated our Terraform TF state. So as you can see, something will be created and Terraform apply TF plan will execute our TF plan. I will not do that today, but yeah, that's kind of the whole idea. And if you want me to continue creating videos on Terraform, on some DevOps stuff, because I haven't created those videos before, just write it down in the comments, and yeah, subscribe to my channel, leave a like. Thank you for watching. That was Andrew and Terraform, and bye bye.